Welcome, deep divers. Ready to explore some really cutting-edge cybersecurity with us?
I hope so.
Today, we're taking a deep dive, a really insightful one, into the Palo Alto Network's Cortex platform. Okay, let's unpack this.
Sounds good.
Now, our source material today is pretty interesting. It's not some dry textbook. It's actually a set of practice questions and explanations for the PSE-Cortex-Pro-24 exam.
Ah, okay. So scenario-based.
Exactly. Which is brilliant, actually, because it gives us this practical way to understand the core ideas and, the real-world uses of this platform.
Right. Less theory, more application.
Precisely. We'll use these scenarios to look at the Cortex platform overall, dive into Cortex XDR for detection and response, get a handle on Cortex XSOR for automation and orchestration. And through these examples, we'll touch on really important stuff like deployment, operations, best practices, all that.
So covering the key pillars.
Yeah, our goal is really to cut through the noise. Use these specific situations to get you up to speed fast on what Cortex can actually do. We're looking for those, aha moments.
Absolutely. And what's fascinating here, I think, is we're aiming to go beyond just what each part does.
Right.
Our mission really is to understand the why. Why was Cortex designed this way? How did these pieces fit together? And look, most importantly, how does this actually solve the tough security problems businesses face every day?
That why is so crucial.
Yeah. So as you listen, try to think about that bigger picture, how each component helps make security operations, well, more agile, more efficient, and ultimately just stronger. That's where the real strategic value lies, I think.
Totally agree. And speaking of agile and efficient, in today's world, speed and accuracy are just everything.
Absolutely critical.
Which brings us neatly to our first big topic, how Cortex helps teams orchestrate and automate their threat responses. Here's where it gets really interesting, because we're talking about shifting security from just reacting to actually being proactive.
A fundamental shift. Let's get into it.
Okay, first scenario from our source material. Picture this. A security team, they're just swamped with alerts, right? Struggling. Which Palo Alto Networks platform helps them by automating responses, tying different security tools together, and managing the whole incident lifecycle?
We're talking end-to-end management here.
Yeah, bringing it all together, automating actions, seeing it through.
Right. Well, the answer that's really changing the game here is Cortex XSO.
XO, okay.
XO. It stands for Security Orchestration, Automation, and Response. And its core job really is to unify all those different security tools a company uses. Firewalls, endpoint security, threat feeds, you name it.
So connecting the dots.
Exactly. Then it automates workflows, we call these playbooks, to manage an incident right from detection all the way through fixing it.
Playbooks, got it.
And look, this isn't just about saving a bit of time, it's a whole new way of working. Security teams used to rely so much on manual steps, right?
Oh yeah, copy-paste nightmares.
Totally. Leading to burnout, mistakes, dangerous delays. XSR helps fix that by basically writing down expert knowledge into automated steps. Smaller teams can handle more, and you get a consistent, high-quality response every single time.
So it levels the playing field a bit.
It really does. Now, other platforms like Prisma Cloud or XDR, they're vital too. But for specific things like cloud security or detection, and Cortex Data Lake, that's for storing data. But for that overarching orchestration, that's XSR.
That consistency point is huge. I mean, what's the typical manual bottleneck you see companies wrestling with before they bring in this kind of automation?
Oh, easily the biggest one is just the sheer number of tools and the fact they don't talk to each other.
Right, the silos.
Exactly. An alert pops up here, you manually copy data over there for more info, then you manually take an action in a third system to stop it. It's slow and prone to error.
Yeah, I can see that.
XOR just automates all those handoffs. It changes everything.
Okay, so that's the core idea.
Yeah.
But how does it work in practice, especially with complex networks?
Well, to make that automation really effective, especially in today's kind of hybrid, spread out environments, XOR uses something called an XOR engine.
An engine.
Yeah.
Okay.
So let's take the next scenario. What's the main job of a Cortex XOR engine in a distributed setup? Is it the user interface? Is it where all the data comes together, or something else?
Distributed makes me think it's not the central hub. It sounds like it needs to be closer to where the action is.
You are spot on. The answer is B. It executes playbooks and integrations closer to the target systems.
Ah, right.
Think of the engine like a lightweight agent you deploy out near the edge of your network, or maybe in a specific cloud environment or a remote office.
So it's like a local worker bee.
Exactly.
Oh.
It lets those automated playbooks run integrations right next to the systems they need to interact with.
which means faster responses, I guess.
Precisely. It cuts down latency, that critical delay during an attack. And importantly, it means you don't have to expose your internal systems directly to the internet for the main Exos platform to manage them. That's a big security plus.
Makes sense. Better security posture, too.
Definitely. And if we connect this to the bigger picture, this distributed execution is just fundamental for fast, effective response in today's world. Multi-cloud, remote workers, everywhere.
Yeah, networks are complex now.
Right. So this ensures the speed and automation of Exos work effectively, no matter where your systems actually are. Minimizes the attack surface, wherever it might be.
That's clever. Ensuring security keeps up with how IT actually works now.
So these playbooks you mentioned, they seem like the real powerhouse of X's.
They really are. The core of the automation.
Yeah, our sources really emphasize how versatile they are, like a Swiss Army knife for security automation. We've got 2 scenarios here that show this off perfectly.
First one. A security team needs to automatically add threat intel from a third-party source to their incidents. Which XOR feature is best for them?
Enrichment.
And second, which XOR feature lets a team standardize their response procedures, making sure every analyst follows the exact same steps for, say, a specific type of incident?
Consistency. Okay.
Right.
Well, for both of these, the answer is clearly the XOR playbook.
Okay, makes sense.
For that first scenario, enrichment. Playbooks are fantastic. An incident comes in, the playbook automatically queries your threat intel feeds, pulls in reputation scores, maybe related malware families, stuff like that.
Ah, okay.
And adds that context right into the incident record. Analysts get a much richer picture instantly without digging around manually. Dashboards show metrics, indicators store threat data, but only playbooks automate that enrichment process.
Saves a ton of manual lookup time.
Exactly. And for the second scenario, standardization. Playbooks are the absolute cornerstone. They define the precise step-by-step process for handling each incident type.
Like a recipe for response.
That's a great analogy. So whether it's phishing, malware, data leak, every analyst, no matter their experience level, follows the exact same steps.
Wow.
Think about it. Consistency, fewer errors, nothing gets missed, even when things are frantic or during shift changes. A playbook could automatically isolate an endpoint, block an IP, notify the right people, open a help desk ticket, all in seconds.
That's incredibly powerful.
It prevents those inconsistent responses that can make a breach worse or leave cleanup incomplete.
So automation and standardization. Yeah. Quality control for incident response. Sounds amazing.
It is.
But let's be realistic. What if a customer needs something totally custom, something not built in? Our source material has a good question on this.
The custom integration question. Very common.
Yeah. What's the right thing to do when a customer asks for a custom XOR integration for some new product during a proof of concept, a POC?
Right. This happens all the time. The correct answer here and the practical one is B. You tell the customer it can be built, absolutely, but it needs a separate professional services engagement after the POC is done.
So manage expectations up front.
Exactly. Building custom integrations takes real development effort and expertise. A POC is usually about showing what the platform already does well, its core value. You don't typically start new development projects during a POC.
Right. Focus on the existing capabilities first.
Yeah. So be clear. Custom work is possible, but it's a paid project handled by professional services once they decide the platform is the right fit based on the POC.
Got it. Set realistic timelines and budgets.
Precisely. And this actually raises an important question, or rather highlights the value of professional services. Integrating new tools, building custom stuff effectively, it's complex. Using professional services ensures those custom solutions are solid, secure, and supported long-term, not just hacked together quickly for a demo. It's an investment in a stable setup.
That's a really practical point about implementation. Okay, so we've covered orchestration and automation with XSOR. Let's shift gears now. Let's talk about another critical part of modern security: detection, investigation, and rapid response. This is where Cortex XDR really comes into play, right? Helping analysts understand and stop threats fast.
Exactly. XDR is about that deep visibility and response capability, primarily on the endpoint, but also correlating network and cloud data.
So what does this all mean for real-time security? Let's look at another scenario. This one really shows off XDR's power, I think. During an investigation, which feature visually shows the sequence of events and how they're related, helping an analyst quickly grasp the attack timeline and find the root cause.
Visualizing the attack.
Yeah, if you ever stared at raw security logs, it can be overwhelming.
Oh, absolutely. It's like finding a needle in a haystack.
Yeah.
And the answer here, the feature that really empowers analysts, is see the causality chain.
Causality chain.
Imagine a complex attack, right? Malware moves sideways, creates new processes, talks to servers online, tries to steal data.
A whole chain reaction?
Exactly. Trying to piece that story together from raw logs takes hours, maybe days. You miss stuff. The causality chain visually links all those related events, processes, files, network connections in a clear timeline.
So it draws the picture for you.
It really does. It paints this undeniable picture of how the attack unfolded, letting an analyst zero in on the root cause incredibly fast. Maybe it shows a normal application being exploited to run a malicious script, which then connects to a command and control server. That visual link is a game changer. It turns chaos into clarity.
Wow. No more sifting through endless logs. You get a clear story of the attack. As someone who's definitely stared at too many log files, that sounds like a superpower.
It kind of feels like one sometimes.
Have you seen cases where that chain revealed something that might have been totally missed otherwise?
Oh, absolutely. A common blind spot is lateral movement. An analyst sees an alert on one machine, right? But the causality chain might instantly show that the attack actually started with a phishing email on a different computer, then hopped through several internal systems before triggering that alert. Without that visual link, you're often just chasing symptoms.
That's invaluable context.
Right.
Okay, so the analyst uses the causality chain, identifies something bad, maybe a suspicious file hash. How do they make sure that new piece of intel helps protect the network going forward?
Good question. Proactive defense.
Yeah. Here's the scenario. An analyst wants to create a new indicator of compromise, an IOC, based on a suspicious hash they found. Where can they manually create this IOC and share it across the Cortex platform?
Right, taking that finding and operationalizing it. The place for this is B, in the IOC management section within Cortex XDR.
IOC management, got it.
Indicators of compromise, IOCs, these are the forensic clues, right? File hashes, IP addresses, domain names that signal something bad.
The breadcrumbs.
Exactly. The IOC management section lets analysts manually create these indicators based on their findings. But the key part is they can then share them across the entire Cortex platform.
So it's not just stuck in XDR.
Nope. If one analyst finds a new malicious hash, they add it to this central list, and then other tools using Cortex, maybe the firewall, maybe XOR playbooks, can immediately use that IOC for detection and blocking.
So it instantly improves your defenses everywhere.
Pretty much instantly, yeah. It operationalizes that threat intel super fast. It's not about policy rules directly or incident management in general or wildfire sandboxing. It's specifically for creating and managing those actionable indicators.
That's a really powerful feedback loop, taking what you find and immediately using it to get stronger.
Definitely.
But with all these capabilities, all this sensitive data, controlling who can do what is obviously critical.
Hugely important. Access control.
Right. So what's the main purpose of role-based access control, or RBAC, in Cortex XDR?
The main purpose of RBAC, simply put, is D, to grant different levels of administrative and user privileges based on predefined roles.
So matching permissions to job function.
Exactly. It ensures users only see and do what their specific job requires. A junior analyst might just view incidents. A senior analyst could maybe isolate an endpoint. An architect might configure the whole platform.
The principle of least privilege.
Precisely. It's vital for security, for compliance, and just for preventing mistakes or misuse of powerful tools. RBAC is purely about user permissions and roles, not about picking security policies or device connections or IP restrictions.
Makes total sense. Precision and permissions. Okay, last XDR question. When an actual exploit happens, what's the fastest, most effective automated response?
The immediate reaction.
Yeah, scenario. An exploit protection module, an EPM event, is triggered in Cortex XDR. What's an immediate, effective automated response action?
Okay, EPM triggers, that means something serious is happening, like a memory exploit, a buffer overflow attempt.
Bad news.
Definitely bad news. The most immediate and effective automated response in that case is A, placing the endpoint into an isolated state.
Quarantine it immediately.
Think of it exactly like that, an immediate targeted quarantine. It instantly cuts off that endpoint's network access, stopping the threat from spreading sideways.
But you can still manage it.
Crucially, yes. It usually maintains management connectivity so the security team can still investigate and clean it up remotely without having to physically run over to the machine.
That's key.
Absolutely. Other actions like email alerts or reports, they're useful for awareness, but they don't stop the threat immediately. And deleting a user account isn't the right first response to an endpoint exploit. That speed of automated containment is just critical to limit the damage.
Yeah, it really highlights how crucial that automated speed is in stopping a potential disaster. Okay, these XDR capabilities are fantastic, but like you said earlier, they all need good data.
Data is the foundation.
Which brings us perfectly to our third segment, the foundational role of the Cortex data lake.
The backbone, as you called it earlier.
Exactly. Data fuels everything in modern cybersecurity, right?
Yeah.
So let's think about this. Which component of the Cortex platform is responsible for collecting, normalizing, and unifying data from all sorts of sources, endpoints, networks, clouds, for centralized analysis?
The central repository question.
Yeah, where does it all come together?
The component doing that vital job, the true backbone, is Cortex Data Lake.
Data lake. Okay.
Think about a modern company's IT. Security data comes from everywhere. Laptops, servers, firewalls, cloud stuff, even IoT gadgets now.
It's overwhelming.
Can be. Cortex Data Lake acts like this huge smart collector. It gathers all that raw log and telemetry data, cleans it up, normalizes it so it's in a consistent format no matter where it came from.
The normalization is key.
Absolutely critical. And then it unifies it all for centralized analysis. This allows other Cortex tools like XDR and XOR to have one single, rich, consistent source of truth to work from.
So they're all singing from the same song sheet.
Exactly. Without it, you just have these separate piles of information. Impossible to see the whole picture of an attack or connect the dots effectively.
Makes sense.
And what's fascinating here is just the sheer amount and variety of data needed today. Attacks are complex. You need that 360-degree view.
For sure.
Cortex Data Lake makes sense of it all. It turns those mountains of raw logs into usable intelligence, which then lets the other modules like XDR and XOSOR do their jobs effectively. Remember, Prisma SASE is network security, XOSOR is automation, Wildfire is malware analysis. They use the data, but Cortex Data Lake is the engine that collects, cleans, and stores it intelligently.
Wow, so it's much more than just a big storage bucket. It's an intelligent processor making sure everything else works smoothly.
That's a great way to put it. It ensures the right info in the right format is ready at the right time.
Mind-boggling when you think about the scale of data involved.
It really is.
Well, thank you for joining us on this deep dive into Cortex.
My pleasure.
We really hope you're leaving feeling more informed and maybe even inspired to keep digging into these crucial topics. Until next time, stay curious.